Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning class 12 Maths CBSE chapter 4 Determinants. This is one of the very important and very interesting and easiest chapter in maths. And I think this will boost up your marks in board exams too. So now let's begin. First, let me give you all the definition for determinant. You all might be thinking, what is this determinant? I have never ever heard this name. Fine. In the previous chapter, we learned matrices, isn't it? So the next step or the next level for matrices is determinants. So in matrices, we have learned so many functions or tasks that was given to us, and we finished all those. So just like functions was given, like transpose, symmetric, skew symmetric, equal matrices, multiplication, addition of matrices, etc. We added, subtracted, multiplied, everything. But did we find any solution for that matrix alone? Just like operation inside that matrix, nothing was done. You all might wonder, can I do any operations inside this matrix? Of course you can do. That is what determinant. So determinant means it's nothing but a matrix. Okay, that is only square matrix. None other matrix is considered. Only square matrix is considered over here, and we will be finding the solution for that square matrix alone. So till now I'm saying solution. What is that solution? How will I find the solution, you all might ask. Okay, fine. Now let's start. Definition for determinant. A unique number, real or complex, can be associated to every square matrix. A is equal to Aij of order m. I said no, since it's a square matrix, m by n can be said as m. So only they've given only m, order m. This number is called the determinant of square matrix. That is the unique number, no? That is called the determinant of the square matrix. So I will teach you how to find that. Be patient. The determinant of A is denoted by DET. That is determinant of A, or enclosed with a pipe symbol. Or the general form for any determinant is this. Hereafter, even in the questions, we will be learning only these types of determinants. Okay, we will be asked to find the determinant of this matrix, but only one matrix will be given. And there are lots of properties in determinants also. First, you have to know what is determinant. So I think still you will be confused with the word determinant. So now I will just give you the example which makes you clear with the difference of matrix and determinants. So for example, just consider matrix A. 1, 2, 3, 4. Okay, this is a matrix which we already know it. So now I'm writing this as it is, enclosing with a pipe symbol, and 1, 2, 3, 4, just with 2 lines. This is not a matrix, this is determinant. So if I have it like this, then I can perform some operations. Okay, so now I'm going to teach you how to find that solution. So now let's start from 1 by 1, 2 by 2, 3 by 3. A determinant of order 1 by 1 matrix A is equal to A11 is given by. So determinant, I already said you, it will be denoted in such a way. And see, when we have only one element, can we perform any operation? No, nothing can be performed. So 1 is 1 only. So just like that, a determinant of A11 is A11 only. Second one, a determinant of order 2 by 2 matrix A is equal to Aij is given by. So matrix A is equal to A11, A12, A21, A22. So this is the matrix that is given. Okay, for the order 2 by 2. So now I will be finding the determinant. So now let me teach you how to find the determinant. So this is determinant symbol. No, so determinant is equal to, I'm writing this matrix in the form of determinant, that is enclosed with these lines. So as it is, I will be writing only this bracket will be changed to line. Okay, so now I will start performing some operations. Operations here it is multiplication, addition and subtraction. Only these three. So now just keep this X method. I'm going to teach you this X method. So be very clear throughout this chapter. For all the 6 exercises, we will be using this method only. So first like this. So how will we write X? Just like this and like this, not like this and this, no. So we will be starting right from the left hand side and then like this, no. So here we will be writing it like this, but in this determinant we will be going like this. So be very clear. Once more, let me do it like this, from left hand side to right hand side, again from down left hand side to right hand side. Always it is like that only, from left hand side to right hand side in both lines also. Okay, so now I already drew a line from my left hand side to right hand side. No, so from here to here I will be marking an arrow mark. Okay, so when I mark such things, then it means that what? I'm multiplying these two. So A11 into A22. Okay, is this clear? So next I'm moving on to this. So I will be marking one more like this. So I'm getting an X. No, so only I said it is an X method. So from here, my left hand side to right hand side, A21 and A12. Or if you come like this also, it is same only. So I'm just making you very clear that always go from left hand side. So A21 into A12. That's it. So minus for 2 by 2 matrix, first element will be positive and second element will be minus of that element. It can be positive or negative. I'm saying here the general form, here it is positive and here it is negative. Okay, so always you have to go like this only, not like this and like this. So starting from this first element, you have to start from this element to this element, then only from this element to this element, not from this element to this element minus this element to this element. Never. Only from this element to this element, this element to this element. That's it. Next, a determinant of order 3 by 3. We already learnt 1 by 1 and 2 by 2. No, the last one is 3 by 3. Up to 3 by 3 only we will be learning in this class. So, a determinant of order 3 by 3 matrix A is equal to Aij 3 by 3 matrix is given by, this is a matrix. Now, we have already learned 3 by 3 matrix. So, now I am going to teach you how to find the determinant of 3 by 3 matrix. So determinant, so as it is, we are enclosing with 2 lines, that is determinant symbol in general form. And now I will say you the formula to find the determinant of 3 by 3 matrix. So every matrix determinant are not same. So but only thing is that it will be similar. So the next, for example, we learned 2 by 2 matrix. No, so the basic of 2 by 2 matrix will be applied in 3 by 3 matrix. So now let me show you all. First, it is not a condition that we have to take only this or like this. Okay, so in any way we can take, or any zeros, if we have more zeros in any row, we can take that. When we do sums, no, I will just say you some tricks. So just for now, just know the formula. Okay, so first I'm saying that I'm expanding these through first column. So I will write expanding. So through which column you are expanding, you have to say, no, I'm saying for this general form, expanding through column. C1 here represents column 1. Okay, so now my column 1, if I take, this is A11, A21, A31, no. So first I will be taking A11 into, so now I'm having it like this, no. So A11 is from row 1 and column 1, no. So I will be hiding this column 1 and this row 1. So what are the remaining part now? A22, A23, A32 and A33. These are the remaining now. So only I have written it over here. A22, A23, A32, A33. Fine. So next, if I go, see here, when you add these two numbers, 1 plus 1, 2, which is even, 1 plus 2, 3, odd. So here, when we have it like this, no, when we have odd position, that is 2 plus 1 is 3, no. So 3 is odd. So in that odd position, I will be using minus. Okay, so A21, I'm taking this A21. A21 belongs to second row and first column. So I will be taking out this first row, first column and this second row. So what are remaining now? First row in these two elements and last row these two elements. No, so A12, A13, A32 and A33. That only I have written over here. And next I will be moving on to the third row. So element here it is 3 plus 1, which is even. So A31 into, so here if I take, no, this one will be hidden and this one will be hidden. So what is remaining over here? A12, A13, A22, A23. That only I have written over here also. So now this is a determinant. This is a determinant, okay. So now in 2 by 2 matrix, how did we expand? Using X method, isn't it? Next, in the next step, we will be using X method. So determinant A is equal to A11 into A22, A33 minus, no, I said minus A32, A23. Minus next A21 into again X method. So A12, A33, A32, A13 plus A31 into X method again over here. So A12, A23 minus A22, A13. That's it. This is a formula to find the determinant of 3 by 3 matrix. This is very, 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 very simple. It looks tough, but if we have practice, no, it will be the easiest sum. So be very, very clear. Some important notes that had to be made, I have written over here. Only square matrix has determinants. Already I said to you in the previous topic itself, no. So only square matrix can have determinants, and this is one of the important formula for one word. So in the previous year question, even in last year's question, that is 2020, this question was asked, a question was asked based on this formula. So this is one of the very, 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 very important formula, as well as a tricky formula. First you have to know. So determinant K is some constant, okay. So for example, when we take 3 by 3 matrix, so 3 by 3 matrix means when we are taking this K out of the determinant, constant is always constant only, now. So when we take out of the determinant, then it will become K cube. This is cube, okay. This is cube. When it is 3 by 3 matrix, it will become cube. So determinant Ka is equal to K cube into determinant A. This is a formula. And what if we have Aij as 2 by 2 matrix? Then Ka, determinant Ka is equal to K square A. Determinant A. That's it. Whatever order you have, substitute over here in the power of K when you take it out of the determinant. That's it. So this also we will be learning it in the exercise, and this is one of the important formula. Make a note of it. Third subdivision. What is the third note? Let's see. A square matrix is singular matrix. So this also is important note. Why? Because we will be using it in 4th, 5th and 6th exercises. So this is one of the important note to be made. What is a singular matrix? A singular matrix means the determinant is 0. For example, if I have a matrix A I'm having, then determinant of A is equal to 0, means it is singular matrix. So if the determinant is not equal to 0, that is greater than or less than 0, then it is called non-singular matrix. Okay, so determinant of A is equal to 0 means singular matrix. If not, it is called non-singular matrix. This is one of the important note that had to be made. So now we have arrived to a very interesting topic in determinants, that is properties of determinants. So this properties of determinant is one of the important part in this determinants chapter, and this properties of determinants is unfortunately deleted for 12th standard 2020 to 2021. For that batch this properties is deleted. So for others we will have, and this is one of the important properties and very interesting properties. The interesting part in determinants is this part. Okay, so now let us have a gist so that it will be useful for your higher studies also, and for others also it will be useful. Now let me explain you the first property. The value of determinant, this also represents determinants only, remains unchanged if rows and columns are interchanged. So now see, this is rows and columns, isn't it? So in matrix we cannot change the matrix, but in determinants we can do according to our wish, and there are some certain rules. We have to follow those rules and then only we can change. And in determinants we can change column to row or row to column. That is just like a transpose. In matrix, if transpose is given, then we can change column to rows. But in determinant we can say that we can just give a just that we are changing, that is we are interchanging column to rows. That's it. If we just give, that's it. So if rows and columns are changed also, the determinant remains unchanged, they are saying. So finally what they are coming to say is that determinant of A is equal to determinant of A transpose. That's it. If any two rows or columns of a determinant are interchanged, then the sign of the determinant changes. See, I have this row 1, row 2, row 3. So for example, if I wanted to change my second row to first row, like B1 to here and C1 to here, then I have to change my sign. So see, there's nothing. I'm changing this row 1. I'm swapping row 1 and row 2. Okay, so my row 1 will become row 2, row 2 will become row 1. That is just interchanging my rows. That's it. A1, A2, A3, C1, C2, C3. So since I have changed these two or swapped these two, I will be changing the sign of the determinant, that is minus sign. Okay, the negative of determinant. So third one is, if any two rows or columns of determinant are identical, then the value of determinant is 0. See, identical means what? Same as it is, isn't it? So determinant is given. See, just take in columns XYZ, ABC, XYZ. These two are identical. Then it is automatically 0. This is the proven facts. If we do sums, it will be easy for us to understand it more. Okay. So Fourth property, if each element of row or column of a determinant is multiplied by constant k, then values get multiplied by k. So this is somewhat not understandable, right? I will explain you. See, I have some constant k. So ka, kb, kc. Okay, so this belongs to this row. So this row fully contains k. So now I can take it common out. Okay, in determinants, if a row fully or a column fully has some common constant, then we can take it out. Okay, so now I will be taking it out. So I will have k into a, b, c, d, e, f, g, h, I. I will have it in such a way. Now I will find the determinant of it and multiply with this k, or it belongs to the entire determinant. If corresponding elements of any two rows or columns of a determinant are proportional in the same ratio, then its value is 0. That is, see, for example, I have determinant is equal to a1, a2, a3, b1, b2, b3. And I have some constant which is multiplying a1, a2, a3. So in the previous property, I thought, we can take the k out. So here fully in the third row, I have a constant which is common. So I will take it out. So I will have k1 out. So a1, a2, a3, b1, b2, b3, a1, a2, a3. So in the previous properties, we have learned if we have same elements, then the determinant value is 0. No, so therefore they are saying that it is 0. Then the determinant will become 0. Okay, so now let's see sixth property. If some or all elements of row or column of a determinant are expressed as the sum of two or more terms, then the determinant can be expressed as the sum of two or more elements. It's nothing but very, very easy only. See here, a1 plus some lambda, that is some constant, a2 plus some constant, and a3 plus some constant. If the entire row or entire column is added with some constant, then we can split those two determinants, it seems. See, a1, a2, a3, b1, b2, b3, c1, c2, c3. Leaving out this, I'm writing. Leaving out this constants, I'm writing. In the next determinant, yeah, if I have plus, I will write plus. If I have negative, I will be writing negative sign over here. So since I have plus sign in all the three elements, I am writing plus over here, and I leaving out this a1, a2, a3. No, first itself I wrote what is a1, a2, a3. No, so I will be leaving out that, and I will be writing lambda 1, lambda 2, lambda 3, b1, b2, b3, c1, c2, c3. That's it. If we have some constants that is getting added with the entire row or entire column, then we will be splitting the determinant, they are saying. That's it. In property 7, if to each element of any row or column of determinant, the equimultiples of corresponding elements of other row or column are added, then value of determinant remains same. So now I'll explain you with the example. Just consider this determinant a1, a2, a3, b1, b2, b3, c1, c2, c3. Okay, so I have some other matrix a1 plus kc1, a2 plus kc2, a3 plus kc3. Isn't it? So if we have any constants or any other number that is getting added or subtracted throughout the column or throughout the row, what will we do? We will be splitting the matrices. We will be splitting the determinants. So how will we split this? So we will be splitting a1, a2, a3, b1, b2, b3, c1, c2, c3. No, what is the operation over here? Positive. Plus, so I will be writing this as it is. No, so kc1, kc2, kc3, b1, b2, b3, c1, c2, c3. So now, see here, constant is same. So I will take it out. So I will have C1, C2, C3, C1 to C2, C3. So this determinant will become 0. So now I will have A1, A2, A3, B1, B2, B3, C1, C2, C3 as it is. So that is what they have said. That's it. The properties are over. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.